As you can see, the elements in group 2 of the periodic table, beryllium, magnesium, calcium, strontium, barium, and radium, all have atomic radii that increase as you go from the top to the bottom.
So sodium and potassium are both in group 1, right next to each other. And sodium has 3 energy levels because it has 11 electrons, while potassium has 4 energy levels because it has 19 electrons.
As you would naturally think, potassium would have a larger atomic radius because it has one more energy level, is true. With sodium only having 3 energy levels because of the 11 electrons in comparison to potassium's 19, it has a smaller atomic radius due to the total number of energy levels. As you can see in period 2 of the periodic table, the elements lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon all have atomic radiuses that decrease from left to right.
So lithium is on the left side of the periodic table in group 1, and it has 3 protons and 3 electrons, so it has 2 energy levels.
Fluorine, on the right side of the periodic table in group 17, has 9 electrons, 9 protons, and 2 energy levels. You may think that because these two elements have 2 energy levels that they must have the same atomic radius. However, they don't. Because there are more protons in fluorine, there's a higher attraction between the negatively charged electrons and the positively charged protons. Therefore, the atomic radius is smaller because the energy levels are held in tighter.
And in lithium, on the other hand, there are only 3 protons, so the attraction between the negative electrons and protons is smaller, and therefore the atomic radius is larger. Francium has the largest atomic radius and is the most reactive metal.
Because
as the atomic radius decreases from left to right, metal reactivity increases from right to left. This is
because As you just saw, the reason that the valence electron was pulled away by the other element was because of the lack of attraction between the valence electron and the nucleus. However, the reason that the other element could not take the inner electron was because of how strong the positive pull the nucleus has on the electron due to the distance between the two. The nonmetals on the right side of the periodic table have reactivity that has to do with electronegativity, not atomic radius. Atomic radii tends to get smaller from left to right, except for noble gases, whose atomic radii become larger. The rule of atomic radius is general because of the elements aluminum and gallium. As you would expect, aluminum that is above gallium should have a smaller atomic radius than gallium. However, gallium has the larger atomic radius. This makes the rule of atomic radius not absolute because every element doesn't follow the set of rules.